Hi, I'm Dylan Hillman. I'm the head of training here at Sol-Ark, and today we're going to be going over tips and tricks with the Sol-Ark 15K. So starting off with sizing. How many of them do you need? Well, the first thing you want to take into account is going to be the feed to the building, how big the electrical panels are, because you do have 200 amps of pass-through per 15K. So the biggest thing you want to look at is what is the feed from the grid to your building. Most houses in the US are going to be a 200 amp feed, but plenty of them also have a 400 amp feed. And what do you do about multiple panels? So first off, if you have a 200 amp feed, you want to just go ahead and pass it all through the Sol-Ark. It has 200 amps to pass through, you're good to go. That's how I did it on my house, works great. I do recommend a bypass transfer switch though. If you have two 200 amp panels and a 400 amp feed to the building, then you could either go with two 15Ks in parallel to get full pass through of that 400 amps, and you'll be using a combiner and a distribution panel to do that. So meter, combiner panel, two 15Ks, combiner panel, and then the home loads. Or you can have one 15K and power one of those panels and use it as a sub panel. Or you can pull loads from both and put in a new sub panel. I would recommend just going with two though. You can just power everything that way. And then the rest is just taking how much power do you need and dividing that by how much the system can do. So in the 15K's case, you can do 19.5 kilowatts of DC PV connected to it, and you can do another 19.2 AC coupled as well to one unit. So if you need more power than that or more panels than that, obviously you multiply that by the number of systems that you need. Another way to look at it is it can do 15,000 watts of cell back during the day from solar to the grid, and it can do 12,000 watts of backup at night from the battery only. So if your loads are big enough to require more than 12,000 watts, you would just divide your requirement by 12,000 at night or 15,000 during the day, and that would be the number of units that you need. Next up is going to be placement. Where do you put the Sol-Ark? Well, first off, it's rated for NEMA 3R, and it would have been NEMA 4R if it wasn't for this screen right here. So it doesn't like to be in direct sunlight unless you build some kind of cover for it, but it is outdoor rated, so you can put it anywhere outside, anywhere it needs to be, or of course you can put it inside. The only other thing to take into account is that the cooling for the 15K model is different than some of our other models. It's actually top to bottom. So you need to leave space on the bottom and above the unit, but you don't have to worry about cooling on the sides. Next up is going to be panels. So if you're doing DC coupled panels, what you should take into account is that there are 3 MPPTs on the Sol-Ark 15K, and they're all totally independent of each other. So you can do a maximum of 2 strings per MPPT, and since we have 3, you can do a maximum of 6 strings. Now, the strings per MPPT need to be the same length and the same type of panel so that they have the same voltage. But other than that, you're pretty much free to do whatever you'd like. The minimum is going to be 175 volts to start production, and then the maximum is going to be 500 with damage occurring at 550. So some tips and tricks on sizing your strings with the Sol-Ark 15K and a lot of our other models. For a general rule of thumb, with our 500 volt maximum, you can usually do about 9 or 10 panels in series. As a maximum, you have to temperature compensate, and then as a minimum, you want to do somewhere around 5 or 6 panels for most types. Sometimes you can get away with 4 if it's a large, one of the larger high cell count panels. But if you want to avoid doing a lot of this math, we do have a great calculator on our website. We'll put the link in the description, and you can just type in what you want. A lot of the panels are actually pre-saved in that. Just pick what you have, how many you want, and it'll tell you if it's okay or not. Now, another thing to note with DC coupled panels is in most cases, you're going to need to put in some rapid shutdown. So there's a few options out there today. You can use Tigo, their fire safety version, or their optimizer version. And you can also use AP Smart or AP Systems rapid shutdown solution as well. And then Fire Raptor, I believe, will also work. Quick note on powering your rapid shutdown supplies and transmitters. There is an included 12 volt power supply that comes with the Sol-Ark 15K in the wiring area, but it only has enough capability to power the AP Smart transmitter and not the Tigo transmitters. So if you're using Tigo, make sure that you power it with an external power supply that's on the load output of the system so that it still works when the grid's out. Okay, now let's go over some battery tips. With the 15K, you'll notice that there's two sets of inputs for the battery. The Sol-Ark can have 275 amps of continuous usage on the battery, and in order to achieve that, you have to use both inputs. So 2 sets of 2-aught is the most common, and that's what we recommend using from your battery bank. If you only use one set, you're going to be limited to 200 amps. Another thing is that if you're putting in your battery cables, you'll notice that the Sol-Ark 15K comes with a pair of toroids. These need to go, both of your wires, both sets of wires need to plus and minus go through both of these toroids. These are for FCC compliance. It just keeps the radio noise down, but you'll want to make sure that you install those at the beginning because it's a pain to put them in later if you forgot. Another thing to take note of is we have 2 sets of knockouts and 2 sets of conduit here for the battery connection. But due to code, you want to have your plus and your minus together in each one of these pipes so that you don't make a magnetic field between them. So you'll see here that you got plus and minus, and then I cross them over here inside the user area. This is the way you want to do it. If you have all the red on one side and all the black on the other, you're going to get a field between these 2 pipes, and your inspector's not going to like it. Alright, moving on to the AC side, I'd like to give you an idea of the general layout of the most common way that these are installed. So usually you're going to start at the meter, go through a 200 amp fused disconnect, and then from that disconnect, you're going to go to the grid side. Now, I do highly recommend putting in a bypass transfer switch, so a double pole, double throw switch, just in case you need to add a second one of these later down the road, do a software update, service it, whatever. It's really nice for the client to be able to have grid pass-through if the need arises. So you'd put that in between your disconnect and the Sol-Ark. You wire the load of the house to the common side, then you'd have the grid on one end for the load input for a power source, and you'd have the load output of the Sol-Ark wired to the other one. Moving on though, so you get the grid coming in through the grid input of the Sol-Ark. This is 200 amps, and then you come out, we have a 200 amp breaker right here for the load side, and this is also 200 amps. And this is usually going to be wired directly to your main service panel or whatever your loads happen to be. And then this last one is the generator input or smart load output. Could also be an AC coupled input. But this is a 100 amp input, and you can use it for a generator if it's 240 volts, or you can do 2 of the 3 phases for a 3-phase 208 generator, or you can AC couple up to 19.2 kW of AC PV to this input and retrofit applications that way. Okay, so now we're going to do a couple quick notes on paralleling Sol-Ark 15Ks. So with 240 volt applications and for 208 volt applications, you can do up to 12 Sol-Ark 15Ks in parallel. But if you're going to put these units in parallel, it's important to note that when they are in parallel, they act like one big inverter. So they have to have the same battery input, so all your batteries have to be put in common, and then from there to all the Sol-Arks. So they all get their own run from the battery, but a common battery input. And then if you're doing on the AC side, they all need to see each other also. So the load outputs all need to be combined, the grid inputs all need to be combined. It's as if it was one big install. For parallel ports, you're going to use these 2 right here, and if you have to extend the wire longer than the ones that come with the units, those yellow ones, you can. It's just standard Cat5 wire, but if you're going to extend it, I highly recommend that you use a shielded Cat6 or better, just to improve communications between the units so you don't have any issues. If you are going to install more than 3 units, there's this little red block right here with white switches on it. We call those dip switches. And you will need to use those on the extremities. So if I had 8 units in parallel and they're all left to right on one wall, I would turn them off on the last one and on the first one and leave them on for all the ones in the middle. That's going to improve your parallel communications and reduce any kind of errors that you might get with that many units in parallel. So here at Sol-Ark, we do pride ourselves on our engineering support and solar support that we offer. It's 7 days a week. Call us up anytime if you have any questions. We do have an archive of videos as well on YouTube. And feel free to reach out to us for any other questions, and we're happy to help out.